Hello everyone, I am Abhishek Verma and in this video I would be explaining the concepts of linked list. In this video, the topics that would be covered are array, its limitations, why linked lists, and the various types of linked lists. First, coming to an arrays, these are the simplest and the easiest types of linear static data structure means the memory allocated to an array is allocated at compile time. All the elements of an array as shown here belongs to the same data type and are indexed from 0 to n minus 1. In our case, as there are 6 elements, it is indexed from 0 to 5. And all these elements can be constant time accessed by simply writing the name of the array and the index. Suppose if we have to access the 3, we would simply write its index 2 and we can easily access it. All the elements are stored in a contiguous manner means that if one is stored at the address location 100 and taking 2 bits for an integer, 2 would be stored at 102 and 3 would be stored at 104 and so on. And also, since contiguous memory allocation is there, no empty element is allowed in the middle of an array. Now coming to the limitations of array, as previously mentioned, the storage of an array is pre-allocated and is static. Pre-allocated or at allocated at compile time. If we see the array as shown here, all the elements are filled from 1 to 6 and we have to insert an element 7 in the middle, but there is no empty space present in this array. Therefore, a complex position based insertion would be done since we would have to first create a new array which would be having an extra element for this 7. Then 1, 2, 3 would be added, then 7 is added, and 4 is shifted, 5 is shifted, and 6 is shifted towards their new places. This is a complex process. This the complexity can be reduced with the help of a dynamic array. But these dynamic arrays allows us to have resizable or growable arrays, but other problems like wastage of memory and memory inefficiency still persists. Wastage of memory means that if the last two elements are not present but their memory is allocated, it means the memory is allocated for 6 elements to an array but only the 4 elements were filled. The memory is wasted for the last two elements. The limitations of an array can also be understood with this example. An event has to be organized consisting of VIPs and the common people. Suppose 10 VIPs were invited to this event. If the sitting arrangement is allocated using static arrays, then at during the event only 10 seats would be present for the VIPs. If more number of people come with these 10 VIPs, we would be lacking the VIP seats since we do not have an access to extra number seats. This problem can be resolved with the concepts of linked list which would be discussed later in this video. Coming to why linked list. Linked list is a linear dynamic data structure. It means the memory is allocated at runtime instead of compile time, thus resolving the memory allocation problem of arrays. The data element of a linked list is, as shown here, is known as a node. Node contains a data element and a pointer which points towards the next element of the linked list. Suppose we have an example of linked list where the first element is known as a head containing a data and a pointer pointing towards the next element and so on. The last element is represented by the pointer pointing towards a null value, thus signifying the end of a linked list. The elements are stored in a non-contiguous manner, as can be seen that the head is stored at 100 and the next is at 200, then at 300 and at 400, and it can be a different value as well. The elements can be inserted and deleted in a linked list in constant time. Suppose an element has to be inserted in this position. So the pointer of the second node is to be simply redirected towards the new node, and the pointer of the new node has to be pointed towards the next node of the second node as shown, and can be, thus the element is easily inserted in the middle, which cannot be done so easily in the case of arrays. Memory utilization is also more efficient in the case of linked list, since suppose we have to delete this element. So in the case of an array, the memory is allotted to this element and will not be removed even if the element is deleted. But in the case of a linked list, the memory is freed for this element and would cease to exist in the memory, and the pointer of the previous element would simply be redirected towards the null, thus signifying the end, and thus a more efficient memory utilization is done. Coming back to the previous problem of the seat allotment for the VIPs, suppose more people do come with the 10 VIPs, but in the case of linked list, we have more access to lot of VIP seats present in result. So if more people do come, more seats can be taken and placed here for them, thus resolving that issue. Now coming to the various types of linked lists. First, the singly linked list, which we have been discussing till now and can be seen here. Second comes the singly circular linked list, which is a counterpart of singly linked list, with the only difference is that the last element uh, is redirected towards the head instead of pointing towards the null. This creates a singly circular linked list. Now coming to a doubly linked list, which is a modified singly linked list where the data element is a self-referential structure with one more element present, which is the pointer to the previous. As can be seen through this example shown here, the pointer next of the head element points to the previous element, and of the previous points back towards the next, the head, the and so on. And the last element's next pointer points towards a null, while that of the previous points towards a null as well. In the case of doubly circular linked list, instead of pointing towards a null, the last element's pointer points to back towards the head element, and the previous of the head element points towards the last element, thus forming a circle, and a doubly circular linked list is created. This covers the basics of linked list and its various types. Thank you.